Okay, so we got that the surface area of the hexahedron, or the cube that we have here, is 752.64 meters squared. Now we have a third problem here for this cube. So given that each cube-shaped box is 3 meters long, how many of these boxes can you fit inside of this very big volume, a very big cube with a volume of 1,400 metric cube? So how do we do that? So we know that the volume of the big cube-shaped pet room is 1,404 metric cube, and then we want to know how many 3x3. Okay, how many 3x3 boxes can we fit? So this is 3 meters by 3 meters, and what we essentially mean by 3x3 is that all of its side measurements are also free. That means its height is also free. So that's going to be 27 metric cube. Now we want to know how many of these boxes can we fit inside this very big pet room, which is a volume of 1,404 metric cube. Okay, so to do that, we just simply divide 1,400 metric cube by 27 metric cube, and we get how many boxes? 1404 divided by 27, we get 52 boxes. Okay, so that means we can fit 52 27 metric cube boxes inside of this pet room or dog room, or whatever it's the function of this room. Okay, so it's a pet room. Okay, so there you go. So Roark can fit 52 of this 3x3 boxes in this very big cube pet room. Okay, so we have here another Platonic solid problem, the third one. So we have here an octahedron. Arturo wants to create a diamond-shaped container for his mom's birthday present. The surface area of the octahedron-shaped gift box is 327 centimeters squared. Given that the dimensions of the octahedron-shaped gift box is on the left, so this one, A is equal to 4p plus 8. Find the value of p, the side measurement A, and the volume of the octahedron-shaped gift box. Okay, so we're given here that the surface area is equal to 327 centimeters squared, or squared centimeters, and we also know that the formula for solving for the surface area of the octahedron is 2 times the square root of 3 a squared. Okay, so using this formula, we can substitute the values that we have here for the surface area, which is equal to 327, okay, is equal to 2 times the square root of 3, and what's the value of our a? So that's 4p plus 8, and then you just simply square that. Okay, so 4p plus 8 squared. So that will give you 2 times the square root of 3, so that will be 16p squared. Okay, and 32 plus 32, that will give you 64p plus 64. Okay, that's all equal to 327. And if we multiply the square root of 2 square root of 3, or distribute that here to these terms, we get 327 is equal to, okay, so we get 64 square root of 3p squared plus 128 square root of 3p plus 128 square root of 3. And then we transpose 327 to the other side, so we're given this quadratic equation. 0 is equal to 64 square root of 3p squared plus 128 square root of 3p plus 128 squared times square root of 3 minus 327. And again, using the calculator trick that we got from we can use for this problem, using our scientific calculator for quadratic equations, we can get that the value of the first root and the second root p is equal to 0.4 and negative 2.40. And again, since we cannot take a negative root for our variable here for p, so we have to use the 0.4 here. So p is equal to 0.4, and from here we can substitute this value to get the measurement of the congruent sides of the octahedron a, so that's going to be 4p plus 8, and again the value of our p is 0.4, so that's going to be 4 times 0.4 plus 8. Okay, and that will give you 4 times 0.4, that's 1.6 plus 8, so that means a is equal to 9.6 centimeters. Okay, so that means the congruent side measurements of the octahedron shaped or the diamond shaped container for Arturo's mom is 9.6 centimeter. Okay, so now we need to find the volume of the octahedron. Okay, so that's going to be square root of 2 over 3 times a cubed, where a is the side measurement, so that's going to be equal to square root of 2 over 3 times 9.6. Okay, so that's a cube, and that is equal to, which is equal to 417.07 cubic centimeters, or centimeters cubed. So this is the volume of the octahedron shaped the diamond shaped container for Arturo's mom, and the gift box that Arturo will give to his mom. Okay, so that's it. So we found the value of P, 0.4. We found the value of A, 9.6, and we found the value of V, which is 417.07 cubic centimeters. And now we have here a dodecahedron problem. So Rita has a dodecahedron shaped container for her school notebooks, projects, and important personal belongings. She liked the shape of a dodecahedron because of its wonderful symmetry. So the volume of the dodecahedron shaped container is 3,585 cubic centimeters. So find the value of M, the side measurement A, and the surface area of the dodecahedron shaped container. Okay, so we're given here the volume. Okay, so the volume of the dodecahedron shaped container is 3,585 cubic centimeters, and we all know that the volume of a dodecahedron is a dodecahedron is equal to this formula, 15 plus 7 times the square root of 5 all over 4 times a cubed, where a is the side measurement, the congruent side measurement of the dodecahedron. And again, a dodecahedron has congruent pentagonal faces. It has 12 congruent pentagonal faces. Okay, so we have here the side measurement, which is 5n minus 2. Okay, we just substitute that here, and we just need to find the cube of this expression of this binomial, 5n minus 2, and that will give you. Okay, so we have here the formula, 15 plus 7 squared of 5 all over 4 times 125 m cubed minus 100 m squared minus 8 when we simplified, or when we expanded 5n minus 2 raised to the power of 3. And then if we distribute this constant that we have here on the left side, that will give you 957.89 m cubed minus 766.31 m squared minus 61.30 is equal to the volume of the dodecahedron, which is 3,585. And then to equate that to 0, we just simply transpose that to the other side. So we get that 0 is equal to 957.89 m cubed minus 766.31 m squared minus 61.30, then plus, okay, so negative 61.30, okay, minus 3585, okay, because we're going to have to transfer that to the other side, so that's negative 3646.3, okay, so that's negative 3646.3. And from here we can use the Castro or any kind of scientific calculator that you may have to solve for the value or for the roots of m. So m has three roots, m sub 1, m sub 2, and f sub 3, which are equal to, okay, so we have the three roots, 1.88 for the first root for m, and then the second and the third root is equal to negative 0.54 plus or minus 1.32i. And again, this is a complex root and a negative root, so we're not going to use them. So the value for m is going to be 1.88, and from there we can solve for the measurement of the side if we have m as 1.88. Okay, so we can simply substitute that for our value here. So that's 5 times 1.88 minus 2, and that will give you, okay, so the value of A, or the side measurement of the dodecahedron, congruent side measurement all of the side measurements are equal to 7.40 centimeters. Okay, and then we substitute this value to the formula of the surface area of a dodecahedron, because that's one of the things that are being asked for this problem. So surface area is equal to 3 times the square root of 25 plus 10 square root of 5. Okay, 10 times the square root of 5, a squared. So we just simply input, or we put 7.40 here, and then we square it, and the value of the surface area of this dodecahedron container is, so the value for the surface area is 1130 centimeters squared. Okay, so that's how we solve it, by substituting the value of a here on our problem. Okay, so for the last Platonic solid that we have the icosahedron, 20 triangular congruent triangular faces. So we have here Tamaya wants to give her mathematician friend Annie a special holiday gift. So a multicolored icosahedron replica was the gift. The side measurement of the icosahedron is given on the image on the right. So the volume of the said gift is 2,915 cubic centimeters, and we want to know the value of J and the side measurement of A and the surface area of the icosahedron gift. Okay, so to solve for the value of J, we just simply have to use the formula here for the volume of a icosahedron. So the volume is equal to 5 times the quantity 3 plus the square root of 5 all over 12 times a cubed. And we all know that the value of A is equal to 8J plus 9. Okay, so we simply multiply that to 8J plus 9, and then we cube it. Okay, so we get that the cube of 8J plus 9 is equal to 512J cubed plus 1748J squared plus 1944J plus 729. And we multiply this entire term by this constant 5 plus the quantity 3 plus square root of 5 all over 12. Okay, and that will give you, so if we multiply this constant, to each of the terms, we get 1117.03 J cubed plus 3831.60 J squared plus 4241.21 J plus 1540.46. And then we have to transpose 2915 to the other side, so that's going to be 0 is equal to 1117.03 J cubed plus 3831.60 J squared plus 4241.21 J minus 1324.54. Okay, so solving for the roots of J for this cubic equation that we have here at the bottom, we get that the first root, again, we're going to use the scientific calculator. So we have here J sub 1 is equal to 0.25, J sub 2 and J sub 3 is equal to negative 1.83 plus or minus 1.17 I. And again, we cannot have complex roots or negative roots as our answer for our variable. So that means that J is equal to 0.25, and we can use that information to solve for the side measurement of the icosahedron that we have here. So that's 8 times 0.25, okay, and then plus 9. So that's going to be A is equal to 8 times 0.25 is simply 2 plus 9. So A, so the side measurement is simply 11 centimeters. Okay, so we have here the surface area formula for an icosahedron. So that's going to be 5 times the square root of 3, a squared. And we all know that the value of A that we solve is 11 centimeters based from the solution that we have here on the top. So we're just simply going to substitute 11 to A, so that's going to be 11 squared. And 11 squared is 121. And 5 squared of 3 times 121, you get 1047.89 centimeters squared. So this is the surface area of the icosahedron gift of Tamaya to Annie. Okay, so there you go. So we found the value of J, 0.25, and we found the value of A with the side measurement, which is 11 centimeters, and we found the surface area, which is 1047.89 89 centimeters squared, or squared centimeters.